Hi, I'm Bob. Welcome back to the tutorial on solving the exercises for the textbook Microeconomics Theory and Applications with Calculus, the 5th edition by Professor Jeffrey Perloff. We will revisit exercise 1.3 in the last section before continuing our solutions. Suppose we focus on the team with a superstar. The team provides a positive externality to other teams because other teams can attract more audience when playing with it. As the team's supply and demand diagram shows, the social marginal cost should be lower than the private marginal cost when we take into account the positive externality or the marginal benefit the team with a superstar provides to other teams. The competitive equilibrium, EP, is determined by the intersection of the demand curve and the team's private marginal cost curve. The social optimum, ES, is at the intersection of the demand curve and the social marginal cost curve. The social welfare in the competitive equilibrium is the area of A plus B plus E. The social welfare in the social optimum is the area of A plus B plus C plus D plus E plus F plus G. Compared to the social optimum levels, the competitive equilibrium market price is too high, and the equilibrium quantity is too low. To achieve the social optimum, the team with a superstar can lower its market price to the social optimum level. Let's jump to the second section, the inefficiency of competition with externalities. Here's exercise 2.1. Why isn't zero pollution the best solution for society? Can society have too little pollution? Why or why not? Suppose a byproduct of the production of a good is pollution. The supply and demand diagram shows that the social optimum level of quantity of the good, QS, is determined by the intersection of the demand curve and the social marginal cost curve, MC social. It is lower than the competitive private equilibrium quantity QP, but greater than zero. As a byproduct of the good, the socially optimal pollution level is also greater than zero. No pollution implies no output of the good. Social welfare will be zero, which is lower than the socially optimal level. Society cannot have too little pollution because pollution is a negative externality and imposes a cost on society, as shown in the diagram. The private marginal cost curve ignores the pollution cost, leading to a competitive quantity QP which is higher than the socially optimal quantity QS. As a result, too much pollution is produced. Let's solve exercise 2.2. In figure 17.1, explain why area D plus E plus H is the externality cost difference between the social optimum and the private equilibrium. The externality cost in private equilibrium is the red triangle below the externality marginal cost curve up to the competitive quantity of QC. Its area is the same as the upper red triangle because they have the same base of B and the same height of QC. Similarly, the externality cost up to the social optimum is the area of the blue triangle. The difference between the two externality costs is the area D plus E plus H. Let's address exercise 2.3. Let H equal to G bar minus G be the amount that gang G is reduced from the competitive level G bar. The benefit of reducing gang is as follows. We also know the cost function. If the benefit is increasing, but at a diminishing rate as H increases, and the cost is rising at an increasing rate, what are the possible ranges of values for A, alpha, and beta? If the benefit is increasing as H increases, then the first derivative of B with respect to H must be positive. If the increase in benefit is at a diminishing rate, then the second derivative of B with respect to H must be negative. From 1 and 2, A must be positive, and alpha must be between 0 and 1. If the cost is rising at an increasing rate, then the first and second derivatives of C with respect to H must be positive. Beta must be greater than 1. Let's answer exercise 2.4. Applying the model in exercise 2.3, use calculus to determine the optimal level of H. The social welfare is maximized when marginal benefit equals marginal cost. We can solve for the optimal level of H. Which equals A times alpha divided by beta to the power 1 divided by beta minus alpha. H is the amount of pollution that is reduced from the competitive level, and it is positive. It indicates that the social optimum implies that the social optimum pollution level must be lower than the competitive level. Let's go to exercise 2.5. More than 4 times as many antibiotics are used for promoting growth and preventing disease in animals than for human use. The extensive use of antibiotics in livestock contributes to the increase in drug-resistant pathogens in animals that might be transmitted to humans, harming their health. Use graph to analyze the equilibrium and welfare effects of using growth hormones in livestock. The use of growth hormones imposes a negative externality on society. The social marginal cost is the sum of the private marginal cost and the negative externality marginal cost. The competitive equilibrium, EP, is determined by the intersection of the demand curve and the private marginal cost curve. The social optimum, ES, is at the intersection of the demand curve and the social marginal cost curve. Compared to the socially optimal levels, the competitive equilibrium price is too low and the competitive equilibrium quantity is too high. Livestock are overproduced because the amount of growth hormones increases with the quantity of livestock. Growth hormones are overused. We write the consumer surplus, the private producer surplus, the externality cost, the social producer surplus, and the welfare in a table. Private producer surplus is based on the private marginal cost curve, and social producer surplus is based on the social marginal cost curve. Note the relationship between the variables. Social producer surplus equals private producer surplus minus externality cost. Welfare equals consumer surplus plus social producer surplus. The change equals the social optimum minus the private equilibrium. The social welfare is maximized at the social optimum. Compared to the social optimum welfare, the private competitive welfare incurs a deadweight loss of the area of H. Let's solve exercise 2.6. In 2009, when the world was worried about the danger of the H1N1 influenza virus, Representative and Senator proposed the Healthy Families Act in Congress to guarantee paid sick days to all workers. Although the Centers for Disease Control and Prevention urges ill people to stay home from work or school to keep from infecting others, many workers, especially those who do not receive paid sick days, ignore this advice. Evaluate the efficiency and welfare implications of the proposed law, taking account of externalities. We draw the labor supply and demand diagram to tackle the problem. When sick workers ignore the advice and go to work, they impose a negative externality on others and society. It is described by the externality marginal cost curve MCE. The sick worker's private marginal cost curve is MCP, which ignores the cost of negative externality. The social marginal cost is the sum of the private marginal cost and the externality marginal cost. The private competitive equilibrium, EP, is determined by the intersection of the labor demand curve and the labor supply or private marginal cost curve. The social optimum, ES, is at the intersection of the labor demand curve and the social marginal cost curve. Compared to the socially optimal levels, the competitive equilibrium wage is too low, and the competitive equilibrium quantity of labor is too high. The social welfare is lower in the competitive equilibrium than in the social optimum. The former incurs a Davy loss of the red area. The proposed law increases the opportunity cost of working while sick. It rotates the private marginal cost curve toward the social marginal cost curve. As a result, it reduces or even eliminates the Davy loss and raises social welfare. Thank you very much for watching this video and solving the exercises with me today. See you soon. Take care. Thank you for watching this video and subscribing to my YouTube channel. See you next time.